Okay, we got a lesson here on increasing and decreasing functions, and we'll be able to tell analytically whether a function is increasing or decreasing. We'll also use our knowledge of derivatives to determine whether we have a relative maximum or a relative minimum. Okay, so let's first of all take a look at a visual here, and we have a couple of values there, x equals a and x equals b, and we can tell to the left of x equals a, this function is decreasing. And we see there is that the derivative of the function is going to be less than 0 or negative, okay, when that happens. And then in between a and b, we have a horizontal line, so it's constant. And at that point, the derivative will be 0. So the slope of the tangent line will be 0 at that point. And then to the right of b, we have an increasing function, and the derivative will be positive at that point. Okay, so a type of example we can see is the following. All right, we have find the open intervals on which f of x equals x cubed minus 3/2 x squared is increasing or decreasing. Okay, so let's see how we would work that out. And here we go. So there's our function there, f of x equals x cubed minus 3/2 x squared. So the first thing we want to do here is find the critical numbers. And the way we'll do that is take the derivative. All right, so we'll say f prime of x equals, that's going to be 3x squared minus, and then if I multiply 3 over 2 times 2, that's just going to be 3, and then x to the first power. We can then set the derivative equal to 0, and in this case we can do some factoring, so it's going to be 3x and then x minus 1. Which means that our values, our critical numbers here, are going to be x equals 0 and 1. Okay, so at those x values, we know that the slope of the tangent line will be 0. So then stuff's going to be happening around them. Okay, so why don't we we'll move that over here. And what we want to do now is something called a sign chart to determine what's happening around those x values. Okay, so what we can just do here is this. We're going to make a straight line here, and we're going to look at the values 0 and 1. And what we want to know is what is happening with the derivative in each of these sections, okay? So values that are less than 0, in between 0 and 1, and then more than 1, okay? So, and we have some options on how we can do that. You can go either to the original function, to the unfactored version of the derivative. Keep in mind, we're talking about the derivative here, not the original function, or we can go to the factored form as well. So let's just take a look at this. If we are talking about values that are less than 0, we can just pick a value to go with. So we can go with, let's say, -1. Okay, so if we think about this here, this is going to be, all right, 3 times -1, that's going to be negative. -1 minus 1, that's going to be negative. So if we have a negative times another negative, that's going to be positive. Okay, so now we know that the derivative anywhere below 0 is going to be positive, which is the slope of a tangent line, which means it's increasing. Okay, now let's take a look at this right here. We're going to go to 1/2. So let's think about this. If we multiply 3 times a positive 1/2, that's going to be positive. 1/2 minus 1, that's going to be a negative number. So we'll have a positive times a negative. All right, that's going to be negative in between there. And then we can take a look at all values that are greater than 1 and plug it into the derivative. So let's take the number 2, positive 2. And here, if we plug in a 2 here, that's going to be positive there. And then 2 minus 1 is also positive. So a positive times a positive will be positive. Okay, so what we are seeing here is that for everything to the left of 0 below 0, we should see the function increasing, and then it's decreasing between 0 and 1, and then increasing again after that. So if we write this down now, the way we'll write it is we're going to say it's increasing on, and the notation we'll say here is this is going to be negative infinity up to 0. And it's also increasing at 1 to positive infinity. Okay, so that's how that works. And then we'll talk about the decreasing now. And that is decreasing on that middle section there. So that's going to be from 0 to 1. Okay, so that's how we write that out once we've done the sign chart. So hopefully that makes sense. Okay, now let's take a look, and we can see here that we are correct. So anything to the left of 0 or below 0, we were increasing. Once we kept between 0 and 1, we were decreasing, and then after 1, all values, x values above 1, we are then increasing. Okay, so we know we did that right. All right, then that leads to something called the first derivative test. And this is going to help us find minimums and maximums. So first of all, let's start off with, it's kind of long, but it's important. So we got let C be a critical number of a function f that is continuous on the interval that contains C. And then if f is differentiable on the interval except for possibly at C, we'll see some examples of that later, then f of C can be classified in one of a couple of ways. And there we go. So if the derivative of f of x changes from a negative to a positive at C, then that means that it's a relative minimum at that point C, f of C. Right? Think about that. Try to visualize it. We're going down and then up. That's going to be a minimum. And then the second one, we're essentially going up and then down, where we have the derivative changing from positive to negative, and that means that it's going to be a relative maximum. But sometimes we will see situations where the sign won't change at the critical value. So it will be positive, flatten out at 0, and then go positive again, or negative, and then negative again after hitting that critical number. And if that's the case, then it's neither a relative minimum nor a relative maximum. Visually, let's take a look. So those are your minimums and maximums, and we can tell there that the derivative, that's the slope of the tangent line there in blue. So if it's decreasing like that, it's got a negative slope, then goes to increasing, that's a minimum. And then if we go from positive to negative, we are at a maximum. Okay, but we also said sometimes this can happen. We've got a positive, and then it's going to be at 0 for a little bit at C, and then go right back to positive. So that means that at C, it's neither a relative minimum nor a maximum. Okay, and we can actually see that happen with our last example. Okay, so again, we said for here, the work that we did with the derivative was we found out that to the left or under 0, so all the negative values, we had a positive tangent line there, so that was increasing. We had a tangent line that went from positive over to negative. Now, if we picked a point here, we would have a negative tangent line right there, and then back up to positive. Okay, and what we're essentially seeing here is that if we go from positive to negative, we have a maximum. And then from negative over to positive, we have a relative minimum. Okay, so and that's going to help us out when we start to do curve sketching, a little bit more advanced down the road. But this is just a quick introduction to how we can tell if functions are increasing, decreasing, and if we have relative maximums or minimums. So we'll get more practice on this in class, and if you have questions at that point, you can let me know. All right, thanks.